All right, it's 1300, so it is time to get cracking. Welcome to the MLS working group. We're going to be here for about 2 hours. We got lots of slides, lots of presentations, lots of extensions. It'll be fun. All right, it's early in the week, so you may not have seen this. This is the note well. It's a reminder about the IPR policies and any harassment, code of conduct, stuff like that. Summary of the IPR statements are if you know something about a patent, you got to say something. How it works. You can do disclosures on your own, the whole 9 yards. What else we got? No, really well. This is stuff about personal conduct. We'd like to make sure that we keep this professional. No need to attack each other on the whole 9 yards. And if you don't like the way I'm doing things, you can always complain to other people up the food chain, etc. But let's just keep it all professional. It'd be great. All right, meeting tips. Again, the on-site meeting tool. If you can scan that QR code, you'll be in the you'll get into the room, and so then it'll record your presence here. So the next time when we need a room, we'll get a right-sized one. It's also the way we're going to manage the queue because we'll have remote presenters, and we want to make sure that we're able to get them in and out. All righty. If it's all right with everybody, I'll just run the slides, unless somebody really, really wants to do it themselves. All right, so our agenda. Some administrivia, which is this. Hopefully we'll keep it short. Then we have some working group drafts that we're going to talk about. We have one remaining issue in the MLS architecture draft. So Brendan's put together a PR. You must kind of go through and explain it a little bit. We talked a little bit about it on the list and a lot in the repo. And Conrad has like another kind of thought on it, because this is the remaining issue that is stopping us from progressing forward with extension. So we're trying to figure out how to close this out. And so I think there's something that needs to be said. We just got to figure out how much we want to say. Then we start talking about extensions for the rest of the time. So Raphael sent me some slides like minutes ago to actually talk about the base MLS extensions document, which has already been accepted. And then we have a bunch of other extensions that are either directly related to MLS or, as this list starts, the ones that are related to Mimi, which is like the, instant messaging again. And then some more drafts. Oh, I didn't update this bit. Britta also sent me some slides. If we have time, we'll go over some thoughts that she and others have had about doing post-quantum in MLS. So without further ado, did anybody want to bash anything? Well, not me, hopefully. But, okay, cool. Good. All right, so we'll stop this one. Brendan, you're up. I will get the slides going. There we go. There we go. All right.
Okay, hello. I'm here to talk about a PR that I opened, I guess, about 2 months ago on the architecture document to cover invalid commits and access control. So next slide, please. First thing to note is, why is this PR needed? So at last IETF, we talked a lot about encrypted versus unencrypted handshake messages. And as part of that conversation, a lot of reservations came up and were expressed about people not feeling comfortable deploying MLS with encrypted handshake messages. And one of the concerns there that stood out to me was concerns about how to do access control. So, if the group state is encrypted, how do you know who's actually allowed to be in the group and send messages to it? That's a fair concern. And on top of that, sort of as part of exploring this issue, other security issues in MLS deployments have kind of come up, what I'm going to call a forced rejoin attack. And so in particular, Mimi is potentially vulnerable to this. And just to frame the discussion, these are architecture issues. They're not really protocol issues. Nothing is wrong with MLS as a protocol. The issue is more so people are deploying it in a way that introduces these sort of security degradations. And because these are architecture concerns, MLS Arch is the right place to discuss these problems. But kind of on top of that, in addition to architecture being the right document, there's also an onus on architecture to discuss this, because the lack of current text is provably negatively affecting real-world use of MLS and other contexts. So next slide, please. Next slide. So a forced rejoin attack, what is that? So in many MLS deployments that have come up so far, the delivery service is the one who chooses which commit ends a given epoch, not the group members. So if several group members all send a commit at the same time, the delivery service is the one who chooses which commit ends the epoch, and it says this is the commit, this commit wins, the epoch is over, no more messages to this epoch. And of course the problem with that is that the delivery service has relatively limited visibility into which commits are actually acceptable to members. So like a delivery service can't verify the MAC, it can't verify a signature, it can't verify that the encryption works correctly. It can't verify all these things. So the consequence of that is that the delivery service can end up choosing a commit that members are unable to process. And what's typically done when that happens, when the delivery service says, you know, this commit wins, but this commit is not able to be processed, members are just supposed to do an external rejoin, and that's kind of slightly more robust because it's easier for the DS to verify that an external join should work in theory. Next slide. There are a few issues here with this approach. So the first one is that this external rejoin mechanic is meant to prevent a trivial DOS attack. So the DOS attack is where a member sends a commit which nobody's able to process. The DS says this wins, and then nobody can process it, so the group is kind of just stuck and can never go anywhere. So it's meant to prevent that DOS attack, and it kind of does. But you can make the DOS attack again. You can make the DOS attack work again just by kind of adding some extra steps. What this does do is it prevents group members from achieving PCS through updates or commits. Because kind of what you think, if you kind of think in the abstract, what you're doing is you're saying, if I ever receive a message I can't process, and anyone can make a message I can't process, I'm going to throw away all of my secure state, and I'm going to download the secure state from the server and use whatever it tells me the state should be. So that's kind of not great. And also it allows arbitrary modifications to the ratchet tree. So people can change the group in ways that they might not otherwise be able to if you weren't kicked out of the group. You know, if you have like a policy in the group state that says Alice isn't allowed to join this group because she's been mean to me in the past, and then you get kicked out of the group and you come back and that like aspect of your group policy was removed, and then Alice has rejoined the group, you have no way to know if just the DS did that maliciously on its own, or if an actual member of the group who was allowed to make those changes actually made those changes. So those are the main concerns. To unpack that a little bit more, back to what I said, the simple DOS attack here that this is meant to prevent is when a user sends a commit that nobody can process. The delivery service chooses that one is the one that wins, and then no one can move forward. So if you externally rejoin to get around that, it opens up a new kind of DOS attack. So when a user sends a commit that nobody can process, all of the group members are suddenly triggered to externally rejoin. And as part of this sort of cycle of external rejoins, the malicious user can also send a commit with the wrong group info, because while the DS is largely able to verify the group info, there are still things in it that users need to join that the DS can't actually verify. So you can make a group info that looks good to the DS, but isn't actually correct. And when you do that, these other honest users that are just trying to rejoin the group, they end up using that incorrect group info. And they actually end up being the ones who send the invalid commit. And then that triggers another cycle of rejoins because people can't process that commit either. And so they have to rejoin, and you can kind of keep the cycle going infinitely. And what's kind of fun about this is because it's not one person sending invalid commits, it's basically any user can end up sending an invalid commit. It makes it really hard for the DS to identify which user in the group is actually malicious. Next slide, please. So that's the DOS aspect. There's also the post-compromise security aspect.
I'm going to get you.
So the attack here is if Alice's view of the key schedule is leaked in some epoch, we're going to call that epoch I, and Alice sends a PCS achieving update to the group, which is then processed by Bob. At this point, you would think the group is secure because Alice was compromised. She sent an update. It was processed by people, so nobody should be in a compromised state anymore. But what can actually happen is the DS can send a junk commit to Bob. When Bob sees that commit, he immediately gets triggered to do an external rejoin. And when he does this external rejoin, the DS can provide Bob with the group info corresponding to epoch I. And when Bob uses that to rejoin, he ends up rejoining the compromised epoch, and that allows the DS to eavesdrop. So essentially, if there was ever a compromise at any point in the group state, you can use this external rejoin mechanic to put the user back into that compromised state and never allow them to kind of leave that. And in a pure like RFC 9420 implementation, this is all that's needed to prevent the group from ever achieving PCS again. We have sort of talked about like different potential mitigations on the list and in the GitHub ticket, but those mitigations tend to veer a lot more into like actual protocol implementation, where like you're looking at specific things in messages and like trying to verify specific things about messages. So that tends to go a lot more into the protocol like engineering sides of things, which is not necessarily appropriate to talk about in depth in the architecture document. But yeah, Richard?
So I'm just trying to follow along with this attack. I'm confused by step 3 here, where you say the DS sends a junk commit. It seems like the sort of commits we're talking about, which are invalid for some members, are things that only the members of the group can generate, not the DS or someone outside the group. So what, can you expand on how step 3 works in your mind?
So a junk commit is any commit that can't be processed for any reason. So, I mean, you can just like generate random bytes and say this is a commit. And that would be a good junk commit, but it's a junk commit if the signature doesn't verify, it's a junk commit if the MAC doesn't verify, that's what a junk commit is. And the DS can't check any of those things. The DS can't verify the MAC, it can't verify the signature and so on. So that's why it sort of works in a deniability way, where the DS could say, hey, someone actually sent this, and I just couldn't verify that it was junk. Does that make sense?
Yeah, it seems like that's making a lot of assumptions. Well, first of all, if commits are sent in unencrypted, then the DS can verify the signatures because it has all the data it needs.
Right, but it can't verify like the confirmation tag or the MAC or stuff like that. So there's still things in there.
It can't completely verify that it's valid, yeah. But
yeah.
Okay, so but it can at least verify that it's from a member of the group. So from signed by a member of the group, signed by someone who's in the ratchet tree. How about that? It can't verify that it's someone who has the group secrets. But in addition to that, it seems like there's a lot of assumptions baked into here as to how clients process commits that fail for any of those reasons.
Right. Well, in this case that we're talking about where you have the external rejoin mechanic. So the DS chooses which commit wins for each epoch. And if users can't process that, they have to do a rejoin.
Right. My point is like the way you end up in this attack is a certain behavior at the DS and a certain specific set of behaviors at the clients.
Yes.
So yeah, it's fairly specific, yeah.
Brendan, can you speak a little bit closer to the mic?
Hi, Rowan May. So, okay, I'm gonna restate what I think this attack is. So first of all, there has to be a key schedule compromise of one of Alice's devices. And Alice just does an update path, doesn't replace the device, doesn't reinit, doesn't do anything else, just does an update path. The second thing is that the DS maliciously sends a junk commit to at least one other member. And based on the implementations that I've seen, it would need to send a junk commit that already has quite a bit of valid looking MLS. And then Bob would have to be, the policy of the group would have to be set that Bob triggers an external rejoin automatically in this case. Did I get that right?
Sorry, can you restate it? What's the
Alice has a key schedule compromise, and rather than replacing her client or reinitting, only chooses to do an update path.
Does that change the scope of the attack for you if Alice only does an update path? Because I think that it would still work if she does a reinit as well.
It does. I think it changes the scope of the attack. If she does a reinit and there is not a new group is not created, then you know that. Then Alice noted, if Alice does a reinit and the new group is created and Alice is in the new group, then she knows that everything is healed and this attack is not possible. So a simple recommendation would be, if you care about this class of attack, if you have a key schedule compromise and external rejoins are enabled, do a re-init instead of an update path. Problem solved.
Well, the security guarantee here that we're supposed to get from doing any commit is we're supposed to get PCS from any commit. So that seems to kind of change the whole.
I mean,
like,
we
mechanic of
have a
MLS.
variety of other attacks, which we have mentioned and are mentioned in the security considerations, that involve sending a commit that is that has paths that are decryptable to some members and not to others, right? There's nothing we can do to prevent those problems. We can just detect them. So because of the nature of this protocol, we can't solve every possible problem that occurs with them. So I don't really see this as a burning issue. Like, we can solve this particular problem by doing by Alice choosing to do a re-init. And also, if you don't want to do re-inits and you just want to do classic update path PCS repair, you don't need to accept external rejoins. Those are two perfectly valid options for solving this problem. That's all I really wanted to say about this slide.
Okay, thank you. Are there more people with their hand up?
There are. There's Raphael's coming in.
Yeah, yeah, thanks. So I think, unfortunately, I think this is still a valid attack, but it's very, very subtle. Because as Richard mentioned, a number of stars need to be aligned essentially for it to succeed. And I think it's important that we understand exactly what the conditions have to be in order for it to work. So one of the things you said on an earlier slide was that the resync mechanism was supposed to prevent DOS attacks. I think it doesn't really prevent them, but it's a way of getting out of that situation. That's just a technicality, really. I second what Richard said. And so in step number 3, what you imply is that any junk commit is immediately going to trigger an external rejoin. And I think that's a big assumption. So for some applications that might be true, but for others who still support resync or the external rejoin, it might take a while until they actually rejoin. Because, for example, the UX might be such that you have to wait for user input. It's not uncommon in end-to-end encrypted messaging apps that you have a series of messages that say unable to decrypt, and only then a user actually pushes a button in order to rejoin. It doesn't invalidate the attack, but what I'm trying to say is that there's a number of things that don't make this as straightforward as it might be. Yeah, and I guess Conrad is going to say more about it in a minute as well.
Raphael, did you say earlier that the DOS attack doesn't work when you have external rejoin for some reason?
No, I meant that the DOS attack, if I understand it correctly, always works, but the external rejoin is only there, to rejoin, not to prevent the attack, but to recover from it. That's what I meant. I think you promoted the external rejoin to a mechanism that it's not. It's not a prevention mechanism. It's only a recovery mechanism.
Got it. Okay, so once the DOS attack stops, then you can recover.
With the external rejoin, yeah.
Okay.
Yeah, that's it. Thanks.
So first of all, thank you for putting this in. I think that the issue you're pointing to is a very important one. This is a known issue in signal-based messengers today. It already was investigated a couple of years ago for what happens with basically a junk update. And as Raphael and Richard already noted, it's application specific. That's why I said most signal-based, not all signal-based messengers, but many of them are affected by this. And why I highlight that is MLS was designed, our baseline was at least as good as Signal, right? And so if we're talking about that sort of correspondence, we are right on point. Now, what you're pointing to is very much an issue because it goes a step beyond that. And how do we address that? And I think that we can get to some nice ways of addressing it. And recommendations, I would recommend that that goes into an extension though, versus into an architecture change here, so that we are keeping to the common baseline as we currently have it.
So I think, I guess the plan is to go through this, then we'll have Conrad go through his slides, which are very much related to this, and then we'll come up, we'll try to figure out what the best way forward is to get this documented in some way. So.
And yeah, and I mean, people have said that Signal has this issue as well, but that is kind of a sad argument because it's kind of, I don't know, letting go of the actual like provable, like simple to understand security guarantees that we have in MLS, because MLS is in a lot of ways better than the Signal protocol in that it's standardized and it supports, you know, large groups efficiently, and also it's supposed to have like this really nice provable security model. And I don't know, saying like, well, Signal is also vulnerable to this is, I don't know, it's sad.
Sure, we can definitely aim higher, and I think it's worthy for us to do so. The issue here is that as the PR is currently stated, it is more of a generic statement of the problems versus a more concrete solution. And there have been a lot of discussions already on, I'll say, nice, elegant solutions to this. And if we go all in to try to address the PCS, it's a matter of like, can we do that nicely and fully versus partially?
Okay, yeah. So you made a comment just a minute ago about sort of abandoning the straightforward, easy to understand PCS updates. But I don't think that's really true. I think that we have a different set of assumptions in environments where we accept external commits. So if you're only going to accept external proposals, we have a different set of those assumptions. And I think that I think it's appropriate to mention these problems in the architecture document, but I think that there is a fairly well understood set of those kind of trade-offs. The other thing I just wanted to clarify about step 3 is for the DS to send a junk commit, I think it would need to send a commit that had a valid signature. So it would need to, I believe that the only way this attack is possible in step 3 is if the DS actually was in collusion with the attacker of Alice's device, and it was more than a key schedule leakage, that it was also a signature leakage.
You don't need to collude with the attacker on Alice's device. I mean, so.
But I think for the DS to send a commit that will trigger an external rejoin in any implementation that I'm aware of, that it would need to have the signature key of a member of the group.
Of some random member of the group.
Of a member of the group.
Yes.
And that's a very different kettle of fish from what you're talking about here. Because as soon as you say that somebody has that level of access, then there's 3/4 of a page of additional attacks that are possible and noted in the security considerations of RFC 9420.
And
just to comment on that, Ron, I think unfortunately you're wrong on that one. So of course the attack is much more powerful if the attacker has a signature key as well, but it still works without the signature key, unfortunately.
And I was also gonna say that it's not clear to me at all that it's necessarily impossible to produce a junk commit by trying to use another user, for example, as like a signing oracle. So if you have this external rejoin mechanic, then it is pretty easy just to give users like, like random group infos or maybe like an old group info and get them to sign a commit under it. So that's not necessarily like the hardest problem in the world, is to get a signature on your junk commit.
So, and Brendan, do you have more slides? Because we kind of devolved into discussion here.
I do have more slides, yes.
Okay, so let me just drop a quick passing thought here, and then I'll get out of the way. It seems like the focus here, given that a lot of this is about automated rejoin behaviors and things like that, that may be the right focus for a PR, but I'll reserve any more thoughts on that for later.
Okay, we've trained the queue.
Okay, so can you go back to that old slide?
You want to go back?
Yeah. So like, oh, no, forward one.
One more?
There you go, thank you.
Okay.
No, forward two now.
Oh, forward, sorry. Apologies.
There we go, stay there. So like I say at the bottom, in a pure RFC 9420 implementation, which is this idea of, I see a bad commit, I do an external rejoin, that's all that you need for this attack to work and to prevent the group from ever achieving PCS again. What's happened a lot in the list discussions is that people have, jumped straight to proposing solutions and saying, oh, well, we can fix this by, checking that the epoch counter is greater than it was before, or we can do all sorts of things. Or like what we kind of just discussed right now, which is the idea of, it's not a junk commit if it is signed by a group member. And like, how can that potentially prevent a thing? But we have a lot of like ad hoc proposals for how to potentially address these issues. And with all these ad hoc proposals, they veer a lot more into actual protocol engineering, and they also tend to not address all of the issues. So what we've been talking about so far is trying to address like the post-compromise security attack, but we don't actually address like the DOS side of the attack. So that's kind of the thing, is we can explore the solutions to these problems. I'm not saying that the external rejoin mechanic is irredeemable. I'm just saying this is a problem and that it does need to be addressed in your implementation, or else you'll have this vulnerability. And in terms of actually how to address it, that's going to be, a lot more complicated. It's going to take a lot of work. It's going to be protocol engineering. And I think that definitely makes sense to go into its own protocol document somewhere. So that's what I wanted to say. Next slide, please. Okay, so what is actually in this PR with respect to invalid commits? So with respect to invalid commits, we have brief descriptions of 3 different approaches to handling invalid commits. The first one is that members choose the next commit through consensus vote. Richard, do you still have your hand up? Okay. Members choose the next commit through consensus. The second option is that the delivery service chooses the next commit, so the DS chooses the winner, and possibly you also have this external rejoin mechanic. That's what we've been talking about so far. And then number 3 is that group members silently ignore commits they can't process. So this approach is a lot more similar to what you would kind of do with any other invalid message, where the DS sends you an application message that you can't decrypt. You kind of just ignore it. You don't like do anything specific. And so why did we decide to talk about these 3 specific approaches? We talk about them because they cover all of the proposals that I've seen for handling invalid commits. So in that sense, they're kind of exhaustive. And then next slide, please. What do we actually say about each of these approaches? So for number 1, for the consensus approach, we say that there is a DOS risk, and also you can potentially force users to stay in a compromised state, because if you send a commit and you block actually processing the commit on trying to find consensus, then you can force the user to stay in a compromised state longer, whereas without consensus, you would be able just to send your commit, see it get sequenced, and then process it. And then you would be out of your compromised state. For number 2, we sort of talk about the DOS risk as well, and also mention how this approach with the external rejoin can allow the DS to revert PCS achieving updates. So that was basically the last 2 slides exactly, where we say, here's how the DOS risk work, this is how the DOS attack can work, and this is how the PCS attack can work. And then for number 3, where group members can silently ignore commits they can't process, we say that this can allow the group state to fork, which complicates the operation of the group in a lot of ways, because you can't think about the group anymore as a linear series of epochs where like epoch 2 follows epoch 3 and then follows epoch 4, and there's only like one set of messages for each epoch. You have to think of it more as like a branching tree because members can choose to accept and process different commits. And that can be complicated to support just on its own. And also if you do want to do some kind of external rejoin and you have a lot of like different head epochs, the DS has to find some way to choose like which head epoch am I going to allow you to do your external rejoin to. So it complicates the operation quite a lot. And the next slide. So what's in this PR with respect to access control? We've got brief descriptions of 2 different approaches. Richard, is your question about the last slide?
I'll just let you finish.
Okay. So what's in this PR with respect to access control? We have brief descriptions of 2 different approaches. The first one is if you have public handshake messages, we say that you can do the kind of obvious thing of just having the DS inspect the ratchet tree and then look at the ratchet tree and see who's allowed to be in the group for each epoch. That's pretty straightforward. I think everyone likes that one. And then for number 2, if you have private handshake messages, we sort of briefly mentioned that you can compute a bearer token from the MLS key schedule, and then you can use that bearer token to restrict access to specific epochs. Because if a user is not in the group state and not actually allowed to participate in a specific epoch, then they won't be able to compute the right bearer token. And so that's kind of clean as well. And then why talk about these specific approaches? Because they cover all of the proposals that I've seen. And also they kind of have complete coverage of handling public and private handshake messages. So that's nice. Next slide. So to recap, the motivation for this PR and the reason that I think it's important is because we've seen implementers and other working groups like Mimi unintentionally reduce MLS's security through their specific architecture choices. And the keyword there is really unintentional. Like if people read this text and they say, I understand all these problems, I want to handle all these problems, that's great. In practice, though, I think that is less likely because what happens is people read this and they think that it's prescriptive. They think that I'm telling them to do something specific. And I think that maybe reflects more so that they're reading it and they are feeling pushed to go in a different direction. And then the PR addresses that sort of unintentional architecture choice by discussing the approaches to handle invalid commits and to discuss the trade-offs between them and the attacks that are possible in different cases. We also discussed, 2 approaches for access control for public and private handshake messages, because I'm not trying to rehash the conversation we had at last IETF about recommending that people use public or private handshake messages. But if people do want to use private handshake messages, I think that we should have text to help them feel empowered to do that. And then, like I said, this is not prescriptive. It's only descriptive. It's just saying if you do X, you will have to deal with problems, Y and Z. Yeah, so that's all I got.
All right, cool. So what I think we're going to try to do is have Conrad do some slides too, and then we're going to loop back. So if I can ask you to sit down, and then when we end up being back here. So Conrad, I'm going to pull the slides up. Think. Confirm my selection. There we go.
Hello. So I'm talking now because Sean, you asked me to kind of summarize the attack, and I think Brendan already kind of did that. So I'll just be very quick about the attack itself, and then maybe jump into a few ways that we can deal with it, as Brendan said, from a protocol design standpoint. So that might be something that we want to include in extension or in an architect, or in the architecture document, or in an errata document for the protocol document itself. So that's kind of a procedural question that I'm not sure of, but yeah, I'll just start with the attack itself. Just to rehash what Brendan just said. So Alice is in a group, and somehow her local state gets corrupted. This could be because the DS did this, or something else does this. And so in any case, Alice wants to rejoin the group. Alice fetches a group info and does an external commit. And now Alice is back in the group. So that's the resync operation without an attack for now. Next slide, please. And the problem here, and that the RFC is not super specific in terms of, or like doesn't prescribe a lot of checks in terms of how Alice should look at this group info before she actually rejoins. So Alice was in Epoch 1, it's this kind of chain that you can see there, then switched to Epoch 2, and then to Epoch 3, and now, next slide, please. Her state is somehow compromised. Could you switch to the next slide, please, Sean? Thanks. And next slide again. Sorry, this is kind of a stepping through slide.
Okay.
So Alice goes to the malicious delivery service, fetches a group info, and now the malicious delivery service gives her the group info for Epoch 1, and Alice does an external commit, and now she's back into Epoch 1. And so if Epoch 2 was Bob's update, then the adversary has just succeeded in turning back Bob's PCS gaining commit. And I agree with Brendan, and this is not or with all the other folks that talked just now, that this is really not a great attack to have, because PCS really goes at the core of MLS, and resync is like, you don't have to do it, but it is an operation that we specify in the protocol specification. So I think we should at least give some more guidance on how to avoid this particular attack. Richard.
Just quick clarification here. This external commit that Alice sends, initially initiating into group 1, or I guess this would be moved to from Epoch 1 to like 2 prime. Like that's not something that anyone else in the group would accept, right? Because they're all at Epoch 3, where Alice has fallen out. And so they would all view this as an old commit on an old state of the group.
In theory, yes, but the adversary could also corrupt the state of everyone else and serve them all the same group info, and have them gather in this false state. Everyone except Bob, of course, who might, well, maybe even Bob, but yeah, Bob might be a bit confused.
Okay, thank you.
So yeah, it can.
So it seems like the fundamental mechanic you're assuming, though, is that the DS can somehow synthesize something and send it to a client that will cause it to do a resync.
That's the precondition, yeah. If the adversary can do that, then we run into this problem. And Brendan has laid out like how this might happen in various scenarios of having the DS controller commits and stuff. Okay, so how bad is this attack? It allows the DS to roll back previously processed PCS update, which I think again goes to the core of MLS, and we should give some guidance on that. There's not enough validation rules with regard to external commits in the RFC to prevent this, to my knowledge. At least I haven't found anything. There might be a bit somewhere saying that you have to, you cannot roll back the epoch, but we'll get to that in a second. And then another comment, as Rowan said, there are plenty of other attacks that are possible if the adversary controls the DS that goes to the direction of denial of service. And so what the DS could also do in this case is just block Bob from doing the update in the first place, and thus you wouldn't have to roll back the PCS update. But the attack that Brandon found is quite a bit more powerful, because the adversary can just compromise Bob and then wait and wait and wait, and at some point in the future, as long as this original group state has not expired because some credential has lost its validity, it can just force everyone to go back to this really old group state where the adversary has all the secrets, or all of Bob's secrets. Okay, next slide, please. So just to kind of give a quick list, we discussed a couple of mitigations already on the pull request. The first one is the kind of easiest one that came to mind immediately, was just saying, okay, if Alice's state failed at Epoch 3, then surely she shouldn't accept a group info that has an epoch lower than that. But then, as Brendan pointed out, you can get kind of a signing oracle for other group members if the DS kind of plays it right, and then the DS can actually get another group member to do a commit and create a group info for an epoch that's higher than the one that Alice is looking for, and so kind of bypass this check. But I still think this check is good to have. Then there's transcript verification, which I'll get to in a second, and then the last one Raphael suggests is kind of have the client keep track of the public keys that have been updated, and then as soon as it sees a group info that has any of the old keys in it, then it just rejects it outright. Okay, next slide, please. Yeah, so quick epoch checking. This kind of makes sense, but the adversary can sidestep it by having Charlie create another commit that has a higher epoch than Bob's original kind of healing commit in the scenario we discussed before. If you would step to the next slide, please. yeah, so Alice's state gets broken again. Next slide, please. And then the adversary kind of blocks Bob's commit to Charlie, and so in the kind of process of time, Charlie does a couple of commits herself, and then Charlie reaches commit 4, uploads a group info for commit an epoch 4, and then the adversary can just give that one to Alice. And in this epoch 4, Bob has never done an update, and so kind of again, the adversary has effectively rolled back Bob's update. So this kind of epoch checking is nice, it's low cost, but it's not a complete defense because it's just an integer and it does not say nothing about the cryptographic state of the group. Next slide, please. Okay, so next one is transcript verification, which is a bit more, yeah, sorry, Rohan. Sorry, maybe I'm rushing a bit too much with these.
No, he said he can wait. Go
Rowan
ahead.
says he can wait.
Okay, fair enough. Transcript verification kind of tries to bridge that gap and get into the cryptographic verification kind of side of things, where Alice, when she requests the group info, she also asks the delivery service to get all the transcript hashes of all the messages that led to this new state that the delivery service is kind of handing her. And so then Alice can actually check that the new state is an extension of the transcript that she last knew as the last good group state that she had, which was state 2, where she had already processed Bob's update. And thus you can see that the new state, like, she doesn't know like what the steps are in between necessarily because somehow her state broke, but at least she knows that this new state includes all the updates that I have processed so far, and so no one can force me to roll back. Of course, this next slide, please. This requires that the DS actually has to keep around the transcript hashes, or people have to forward them to Alice somehow. So this is kind of an architectural requirement here. Next slide, please. And finally, public key bookkeeping, which is also a really nice solution, but does require some client-side bookkeeping, where whenever a client does an update in a group, every client that processes the update keeps track of the old public keys, or at least hashes of the old public keys. And whenever a client does a resync, it checks the public keys in the new group state against this big list, potentially big list of old public keys it has seen in the past. And if there's an old one in there that it knows has already been updated in a previously known good state, then the client just rejects the group state completely. And so this kind of, in terms of kind of total preventing this attack entirely, is, I think, at least on par with the transaction. The transcript hash approach. So yeah, that was essentially my small take on what we can do in terms of protocol engineering. But the question now is, like, do we like these mitigations? Anyone have any opinions on those? And as Brendan said, like, do we want to talk about this in the architecture document and give some guidance? Do we want to have something in the errata for the RFC? Again, like, I don't know if this is how the IETF process for errata works. I've never done that before. And the last one that we could do in any case is have an extension that kind of solidifies this as part of how you do an rsync. Sorry, a resync, not an rsync. Yeah, sorry, Ron.
Hey, yeah, so I'm going to reiterate the reinit for a compromised user in a system that has external commits as an appropriate solution. And I do like the transcript. I don't think we want to put any of this in the architecture document. The document has been through 2 working group last calls. It's time.
Fair enough.
So I think it'd be very relevant for the working group to address these in detail. The challenge with the architecture document is that it's, again, not prescriptive, and the details as they currently stand in the PR basically punt the problem. Because if we say we require bookkeeping for public keys, or require consensus, or any of these sorts of approaches, if that's not a very detailed description of how to do it well, then it's just leaving it up to the implementation where they think they may have solved the problem. They actually didn't solve the problem. And that level of detail to how to do it well, I don't think can fit neatly and within the guidelines that the architecture document needs to hold, which is non-normative. So an extension or potentially few extensions on how to solve this for applications where it's a problem would be very relevant.
Working title, external join considered harmful. Automated external resync considered harmful. I think it's probably accurate to say that like the risks of taking a group info from the DS are not like deeply explained in RFC 9420. Doesn't rise, I think, to the level of errata, but I think that this could use more discussion. I do think it does seem like the core of the issues that in both of these presentations is this automatically triggered resync behavior on errors. So I think that's probably where I would focus the architectural discussion, is flagging that as a potentially problematic, as the resync operation being a risky thing because you're accepting information from the DS. And especially dangerous when you're doing it automatically in response to some protocol circumstance. So I think that's about the right level on which I would address this. For the details like you've discussed here, Conrad, I think those would be really great content for an implementations document, which we've discussed off and on in the past, to cover things like how you use the DS tracking the ratchet tree to speed things up and things like that. So like going deeper into some of the mitigation strategies, I think could be really good for a much more technical document like that an implementer could sit with and ponder which of these mitigation strategies could make sense in their application. And as Britta said, like lay them out in some detail that could be usefully, you get hard guarantees out of. Just kind of completely independent of what I was just saying, just to throw out something that another kind of use case where to highlight that this resync case this external rejoin case is not the only resync case. In WebEx today, the way we handle invalid commits is we crash the MLS session and rejoin with an internal join. So you emit a request to join the group and you are added by someone else who's in the group, which works great in real-time case. Real-time is a weird case for this in a lot of ways. But it's useful as an intuition pump to say, maybe we haven't covered, maybe this isn't inherent to the protocol. So that's why I think focusing on the automated rejoin stuff is not inherent to the protocol because we're operating in different ways today. So I think it's something we can safely say, like, yes, you should pay attention to this. Like this is, you should focus on this as a potentially dangerous issue.
Yeah, I'm not sure. So we might want to have this implementation talk, and you're right. We might want to tackle this now that we have some more experience with implementations and deployments. But I'm not sure this should go in it because it kind of goes into the heart of the protocol mechanics and verification of stuff, and when we get which security guarantees. So I'm not sure that's the right place. Like if we don't want to have it in errata, that like again, that's fine. I'm not sure what the process is there. But I think I'd rather have it as an extension, than have it in a kind of implementation guidance document. That seems a bit,
Well, it seems
odd.
like implementation guidance to me in that it's kind of talking about how you respond to the errors that the protocol emits, right? So we have this boundary where things are fed into the protocol, and you get either good results or bad results, and this is about how you respond to the bad results. And you may want to like do some nuanced processing here. Like you might treat failures of the membership MAC differently than you treat signature failures and differently than you treat decryption failures, right? Because those have pretty different consequences, pretty different semantics. So yeah, this is like deep technical stuff to really get into how you should do that. But it's all about how you kind of externally to the protocol, how you as an application react to this stuff.
Fair enough. Brendan.
Hi. So I'm not sure if this is like off topic at this point in time, but Richard, you've said a couple of times now that you think the pull request should be restricted to just basically saying like external rejoin is bad, be careful, instead of discussing the other approaches. And I'll say that I don't like that answer because it seems to presuppose that the right answer for deploying MLS is this model where the DS chooses which commit is right, and then you have some kind of system for like figuring out like what to do when a commit can't be processed. Yeah, it seems to kind of presuppose that that's the right answer, and it's not clear to me that that's an approach that's actually workable, like in a secure way for anybody, much less all applications. Because we've already gone through a lot of rounds of cryptanalysis where people, say, or where I say like, oh, this is like insecure for some reason, or it doesn't work for some reason. Then people will say like, oh, well, we can fix it if we do this. And then like that changes the attack a little bit, but it's still, insecure. You still have the DOS attack. So then we make it a little bit more complicated, and we kind of keep changing it and doing the protocol engineering to fix this approach up front without actually ever reassessing if this is actually the good top level approach.
Yeah, so I think I agree with Richard that the scope of the architecture document should really be a stern warning that that stuff can potentially be dangerous if it's not really thought through. But we cannot have details in the architecture document, like Britta pointed out earlier. It's not a normative document, so it really should be elsewhere. I don't have a really strong opinion on whether it should be in an implementation document or in a dedicated document, but I want to note that we've been talking about that implementation document for a while, and it never, magically sprung into existence. So I want to make sure that we, decide on something that's actually actionable. And I think we should just, start writing down the mitigations here. To the extent that we're confident that they actually work, so that we don't end up in the situation Brandon just described, where we do half-baked mitigation and then effectively we've just changed how the attack works. So we want good mitigations, and it doesn't really matter what that document is called, because we can still think about that at a later point in time. If we grow the scope to handling other things as well, then it might well turn into the implementation document, but we shouldn't maybe not be that ambitious right now.
I want to highlight that if we have the full compromise case, which is what Brendan had mentioned as one of these cases, then the solution of tearing down the MLS session and restarting it that was mentioned actually doesn't solve this problem, and you're actually still vulnerable to attack. In fact, it's more ideal from the attacker's point of view because they have a copy of the key packages and whatnot. So there's various possible things that can be done here, but they do need some exploration, and it's probably worth writing those out in detail and possibly analyzing those in detail to show that they actually are achieving the guarantees we want them to achieve. So I agree absolutely with Raphael and with Brendan as far as stating that this is a problem in the architecture document is probably worthwhile, but we need some sort of thoroughness and rigor to the proposals that we're putting out and backing for those. So some sort of extension or something beyond that's a little bit more formal than an implementation guide, I think would probably be the right way to go.
Rowan, I think you're next on the list. No, or not?
So I was just going to plus one what Britta said. Like, I think the right balance here is to describe the problems here. I think we have arrived at a pretty coherent agreement on what the problems are. Things like, avoiding the delivery of invalid commits and responding properly to invalid commits in non-risky ways. And then we should absolutely dive into the details in another document.
Okay, so we're at the point where we've drained the queue on both of these presentations and we need to figure out what to do. So in the GitHub repo, it has been proposed that we do nothing, which is one thing. Then we have Brendan's proposal on the other side, which is to be more explicit. And then there's a couple of places along in the middle that we've talked about.
Is what's in the document, does it contain the problem? Does doing nothing include?
Sorry,
No, we're
can you
not.
say
We're
that on
not.
the mic?
I guess the point I'm going to make is doing nothing is not on the table for real. If we just spend an hour talking about it, we got something we got to say, right? Yeah.
Just a clarification, is what's in the architecture document, does it include the problems or not? What's there now?
I mean, please have the authors.
Do we know what?
I agree with Sean's assertion. The fact that we've had this discussion illustrates that the document is not sufficiently clear on this point.
Oh, do you want to know about what's in the document or what's in the PR? What's in the document? Okay.
Rowan is doing his own review of the document.
To answer your question, what's in the document currently doesn't discuss any of these problems at all, which I think that we all agree is a problem because it's negatively affecting, real world use of MLS. What the pull request does is it does discuss this problem, but it also discusses the other optional alternative approaches to solving this other than just having the DS choose which commit is correct. Because we can have one approach, which is have the DS choose which commit is correct, and we can discuss the problems with that. But I think it's also worth it to say that there are other options and other avenues to explore here so that people don't get stuck kind of going down this one path without ever like thinking, is there another way?
Okay, well, is there anybody else that has any thoughts on this? Because it sounds like it seems like there's an agreement that we have to describe the problem. The amount of text that goes in the document to describe the ways to solve it is what I think what we're spinning around on, or where to put that text. And so it seems to me like we have a couple of options. We can just put the problems in and kind of punt on what the actual solutions are, or try to keep iterating on what the actual solutions are. So yeah, just yeah, come. That's where I'm going. Yeah.
So we're not discussing solutions at all here. We're only saying these different approaches have these different problems. And we're not being prescriptive about which approach people take. We're just saying these are the options. These are the problems they have. Actually solving the problems, I think that we all agree is, somewhere where a different document would come in.
I do not agree that that's what the current PR does. The current PR makes a number of recommendations and is very speculative. That is not consistent with what you just said.
There are no recommendations in that PR. I don't understand. Like, what's text that says that to you?
Yeah, so to that, the current PR proposes these possible methods of, like, for example, the consensus and the bookkeeping of public keys as possible ways.
That's not what my PR says, no.
It lists those as possible ways that should be considered for addressing this.
Not in my PR. Like,
Does your PR list these methods at all or mention them?
No, it only says like this is the approach. It has the PCS and the DOS risk. You need to address these in some way if you're going to use this approach, or accept that they can happen, I guess.
Okay. My reading of that just before this meeting showed that those were mentioned as considerations and trade-offs in them. But maybe if your goal is just to state the problem, then maybe that is where this discussion is going anyway, that we just want to make sure that the PR explicitly states the problem and not any possible solutions to it. And then that gets taken and done thoroughly elsewhere.
Yeah, I definitely agree with that. That's what the PR should be. Okay. And I think that you said like the public key bookkeeping idea is mentioned. I don't think that that's in the PR.
Hello, PR number 261, line 845. One solution to this problem might be to require group consensus on a commit. For example, there are a number of statements like that. And that was just me like looking very, very quickly to find something. So I think that there are a lot of statements that people would construe as recommendations.
Right, but that's not a recommendation. That's doing what I said, which is saying like one solution to this would be to do X, and if you do X, you're going to have
Yeah.
the problems.
To be clear, I oppose having anything that says solution, recommendation, like just problems. Problems, all good. But yeah, one solution, one possible, like, no, I'm not okay with that.
I don't understand how to phrase it then, because to, talk about the problems that you have with a specific solution, you have to describe that approach, right? Like, what is the phrasing that would be better for you?
So I think what Rowan's pointing to here is that you could describe the original problem with the whole resync without describing solutions or problems with solutions. So if we punt the question of the solutions and the problems with those solutions to however we're going to address it as a group, and only focus architecture to mention this original issue and say something should be done about this and leave it there, then my understanding of what Rowan's saying is that he'd be confident and happy with that.
But it sounds like what you're saying then is that the PR should only discuss the external rejoin approach. Right, that's only one way to solve the problem of having invalid commits. Because the core problem here is how do you handle invalid commits? The external rejoin is the solution that people have to that, and then you get more problems from that specific solution to invalid commits.
So there's the external rejoin as a solution to some sort of invalid commit. It's not the solution to the problem that you're describing, which is all the security implications thereof if it's done incorrectly. It is a functionality option that is in the original protocol. So what I think you're pointing to is that there's other ways of looking at this, of that the PCS issues and whatnot. And instead of us saying in this architecture that doing external rejoins is a solution for something, to just state by using that functionality option in the protocol, you have these potential insecurities and you need to address them in some way in your implementation and leave it there. Then you haven't gone into the solutions to that problem yet. Does that?
Well, okay, so let me ask you then, if we say, if you do the external rejoin mechanic and then you have these problems, how do you phrase it without saying, one solution to the invalid commits problem is this external rejoin mechanic, and then that introduces these vulnerabilities? Because that's what it sounds like. That's what I believe Rowan is objecting to, is the phrasing of saying that external rejoins is a solution to the invalid commits problem.
So if you stop that sentence right at the point where you say, and a solution to this is, then I think you've cut it at the right place.
But if we say just external rejoins, then we're discussing that without the context of why that mechanism is used.
Yes. I don't think it's necessary. You've got primitives in the protocol. And so saying that, like, if you use this combination of primitives, you're going to see this problem.
But to be clear, this is not a problem with external rejoins in the abstract. This is a problem with external rejoins as a way to handle invalid commits. Like,
no, I think you can express it as, here is a combination of actions. If you do these protocol actions, you're going to see this problem.
Right. The protocol action is if you see an invalid commit and you do an external rejoin, then you have that PCS and DOS risk. Because
it doesn't matter whether the reason was because you saw an invalid commit. It could be somebody else who came in who was joining because they wanted to join the group, right?
No, like if you're joining a group just like fresh, like because you want to join a group and like you join an old compromised group state, that's a completely different vulnerability from saying that I was in like a PCS achieved state, and then the DS used this mechanic specifically with invalid commits to put me back in an insecure state.
What I'm saying is that there is a combination of primitives that are used that causes a problem. And documenting that is great.
But then we're only documenting it because it's the specific approach that people have used to solve this one problem. And we're not discussing other ways to solve invalid commits. We're only discussing the external rejoin like vulnerability because this is something that people are using to handle invalid commits, and then we're like not talking about the invalid commits problem and like other ways to approach it that would not have that same issue.
So there's two problems here. There's the functionality issue and the security issue. The functionality issue of a corrupted commit, the external rejoin gives you options to solve. But what you are highlighting with this in this discussion is that there's a security issue in the realization thereof. That if you use that to solve the functionality problem, you now introduce a security problem for your PCS. And the discussions of the solutions to that security problem are what we're saying could be punted to something else outside of the architecture.
Right, but we're not discussing solutions here, or not discussing solutions to the more concrete problems. Like we're saying, this is an approach to solving it. This approach has these problems.
All right. Okay. So I
Okay, I
think
guess
we have we're going to do some hums here, our show of hands tool. But before we do that, who's read PR 261? Okay, great. That's what I figured. So we're after the discussion. I'm glad everyone's informed and has followed along. That's great. Nick, have you got the questions?
Yes, we're going to make two questions. One is yes or no to adopt APR to address this issue. And then the second one is if yes, do we want to list the approaches as Brendan has in his PR, or do we want to completely leave out the approaches and just list the problems with no solutions? Do you have any adjustments to this, Brendan? Yeah, you can say one more thing on the issue before we do that.
Okay, so just to, I guess to repeat myself from slightly earlier, to discuss this one specific external rejoin mechanic and to say, this has these problems, you need to solve it in some way. And to not discuss the other ways to solve the invalid commit problem. In my mind, what that is doing is presupposing that the right answer to deploying MLS is having the delivery service choose which commit is correct for each epoch. And that's not at all clear to me that that is the right answer. Like my implementations have never done that. And it's not clear to me that that's like actually a workable answer, like something that will actually end up being secure and functional in the end if we do this protocol engineering. Because like I said, we've already gone through a lot of rounds of cryptanalysis of people proposing, we can do this to make it work, we can do this to make it work. And a lot of those ideas have kind of fallen through. So we should do the protocol engineering, but it's not correct to presume that this is the right approach to only discuss.
Just real quick, chairs, you feel free to ask your questions, but I feel like Rowan, Britta, Brendan, and I are pretty close on at least in understanding what the issues are here. And so we have a coffee break after this, and it's like, let's sit down and hash this out.
That's my hope.
Okay, we're going to ask the questions to get a sense of this from folks who have read the PR and have heard these presentations, starting with the first one. Okay, so we have more than half the participants have answered, and it's all yes or no opinion. Now, a reminder for this, if adopted is likely going to be a yes. So this is a yes or no question. Yes for listing the approaches and no for including only the problem. Yes for including the lines that Brendan had in the PR that list potential solutions and approaches to dealing with the problem. No for list only the problem and none of the potential solutions that people would take. Sorry, it's not coming up. Let me reload. I'm not able to. My typing doesn't work. Just one second. We've had a couple of votes. Is it not coming up on folks' media echoes? Okay, I'll do one more try. It is working now?
Well, at least I see it.
Okay, we're gonna have to move on for now. I think there's technical issues with the
Yeah.
show of hands.
All right. So we'll come back to that. So
Just to be
Will-
clear on the previous point, anyone who else who wants to join in this little discussion on the coffee break, feel free to join, just find us.
because I mean, what would be ideal is that you guys, since you're all here, figure this out, give us some text, we can get it done, and then we can get the document out the door like this week. So we really appreciate that. Thanks. All right, so now we're going to move on and we're going to have Rowan talk about some extensions. Oh, no, sorry, I'm wrong. This is, first is going to be Raphael. Sorry. Assuming he's there.
We overwhelming 3 votes.
Da, da, da. I mean, it's one slide, so. All right, having some problems. All right, let's go on. Since you're here, Rowan, let's, I'm sorry, switch back to you. Which one is yours? AppSync? It's actually of them. This one.
Okay, so first of all, hi, I'm Rowan. Second of all, apologies to Conrad and Raphael if I repeat something about safe AAD in here. Okay, next slide, please. Okay, so these are all the drafts that I have worked on that are in MLS. So the first thing I was going to mention is a couple of issues on the Safe Extensions framework. Then I've got 2 extensions that I specifically wanted to talk about that are related to Mimi. One is AppSync, which Richard presented in Australia. And the second one is a new one, semi-private message. Next slide, please. Okay, next slide. So Safe Extensions is in section 2 of the draft IETF MLS extensions draft. So I think Conrad and Raphael agreed that it would be nice if we have a way to send additional authenticated data from multiple extensions that where these extensions don't clobber over each other. So basically probably some kind of muxing mechanism. And we need to acknowledge that there may be some non-safe extensions not safe extensions that doesn't necessarily make them unsafe, but that also may send AAD. And so how do we do that? So I have a PR that proposes some stuff. It probably needs a little bit of extra stuff. Please have a look at it if you're interested in this topic. Next slide. The other thing is that in general, Richard and I were preparing the new AppSync and as a safe extension, and the 2 of us came to opposite conclusions about what the what the appropriate place was where a proposal, credential, or wire format extension ends up being advertised for capabilities and in the group context. So I created an issue. It's like a one-liner. It's issue number 30. We need to figure that out. I think one of the problems is that there's sort of an overloading of the term extension, which is used for any safe extension for the ID that you get from Rihanna for that. And then there's another usage of the term extension, which means basically only the extensions that you can stick in leaf nodes, key packages, group context, and group infos. So we might need to just morph those definitions a tiny bit. Okay. Next. Okay, so the AppSync proposal, the proposal for a new proposal type called AppSync, which is a safe extension. Okay, these are basically the slides from before. There's only going to be a couple of changes. How many people here are familiar with AppSync? Okay, not very many people. So I will go over these slides. So first of all, we have, go back please.
Oh, sorry.
So first of all, we have this wonderful thing in MLS called group agreement, and it's a very powerful tool. So this allows us to use MLS to confirm that the group agrees on the state of the group. If you have application state, it would be very nice if we can also have that agreement cover the application state, because applications frequently want that. So let's import the application state into the state of the group. Next slide, please. Okay, so we came up with this. One of the uses, one of the applications that would use this is in Mimi, that we would have a participant list, basically the roster, which is included in the MLS key schedule. And then there was also this idea of sort of generic room policy, like things that admins have the role admin has these attributes or capabilities. And recording is not allowed in this group, but external commits are allowed, those kinds of things. There are several of these things which are operational settings, which are in, I believe, section 7 of the architecture document. This was also discussed that this would be nice to have agreement about what these settings are so everybody could configure their MLS clients appropriately. So an AppSync proposal is used to update a particular piece of application state, and that particular application state has an application ID. Next slide, please. I'm going to skip this. The important, except for there is for each application there is an application ID, and there is some state. And the next slide we will talk about what you can do to modify that state. Next slide, please. So with the draft as it exists, there is a concept of a couple of different types of common representations of state. So either an irreducible blob that you just set completely, or you replace in a single atomic operation, all as a whole piece. There are arrays, which are ordered, and there are unordered lists, and there are maps. Now, there was some pushback about this, that this is really not MLS's business. And so I made a PR number 1, which basically says, okay, this state will be completely opaque to MLS, and it only has the ability to replace the existing state with for this particular application ID with a new state. Now we know that for something like a roster, if I have a roster in a group with 1,000 people and I need to add one person sending the entire roster, this is inefficient. So there's also the idea that you could have an application specific patch operation as well. So these are the choices. We would like more people in the MLS working group to take a look at this extension and see if, regardless of what choice we make along the spectrum of these two approaches and the second approach with patching. Is this something that seems reasonable for us to do?
So it worked for me.
Raphael.
You want to text me the question?
Yeah, sorry. It seems like I had a technical issue earlier. And had I presented, I would have said the following. So it seems we have some overlap between different proposals here. One is AppSync. Then there's one that is already in the MLS extensions doc about extension state. And then there's a third one proposed by Franciscus, but not yet discussed, that proposes updates to group context extensions. So they each solve a slightly different problem or a different aspect of the same problem. And I think we should actually sit down and see what we want to do with all of that.
Okay. All right. Any other comment? Okay. Next slide. I wrote a draft called semi-private message. What is this? So we had, based on a discussion in Mimi about metadata privacy, we had a discussion about how there are a number of applications where a DS would like to be able to see the contents of a handshake message. But in the Mimi context, that would mean that sending a public message would get forwarded through a number of providers, not only the hub, which is the one that is responsible primarily for the DS function. So we already have a concept of external senders that we can use to send external proposals in MLS. So we could have a concept of external receivers for a message called semi-private message. And so you could use this to share handshake messages with the list of external receivers who are in the group context known to the group. This would be an explicit share, so it would be providing less information to everyone else in the world, because it would look like a private message. I mean, it would be a new wire format semi-private message, but in terms of the information that you would be able to glean from the outside world, it would look like a private message. You wouldn't be able to tell the sender of the message, and you would just be able to know the group ID and the epoch. There's also a PR number 79 on the Mimi protocol, which basically describes how to do this in a sort of roll your own way. And so it takes the, well, we'll go to the next slide, describe exactly how it works. So basically you have two keys and two nonces. So you have a key nonce pair to encrypt the sender data. When you decrypt that, you find out who the sender is and the reuse nonce, the reuse guard. Then you also have a key and nonce for the ciphertext, and that's XORed with the reuse guard. And using those four pieces of information, you can decrypt the contents of the private message. So this combination of per message keys and nonces, this is encrypted individually encrypted to each of the external receivers, and it's placed in a vector called keys for external receivers. And so the rest of the message looks basically the same as a private message. So Here we have a semi-private message. The only difference here is that we have an additional element. And then we also have in the instead of private content AAD, we have semi-private content AAD, and that includes additional authenticated data of the key for external receiver. So that's the idea. Would love to have some feedback on this. Thank you. Feel free to go to the next slide. Raphael.
Yeah, sorry, me again. So I think you presented that already in the Mimi group before, and we had some discussion, so maybe it's worthwhile just repeating that here. And that is that I think the proposal is now right in terms of scope. It's a way of selectively giving access to the content of a private message to parties that are at least known to everybody in the group. So that's a good thing. When it comes to implementing it, it's going to be not so nice because it goes through all of the nice layering we try and have, but that's an implementation detail at this point. It's unfortunate that it does not cover the group ID. That's a very sensitive bit of information. So if in a broader scope, the idea is to hide messages from follower servers, for example, essentially anyone who's not the hub, then you might also want to hide that. And this is not achieved here. I don't have a solution for that, but I want to note that we don't have complete protection of that. We're just as good as private messages in that sense. So specifically, when you take these private messages, you don't hold the keys to decrypt them, and you put them in client queues, for example, you can still absolutely correlate who's talking to whom, even if you don't see the content of the proposals in the commits. So you can still infer a lot of stuff that is not protected.
Okay, I just want to mention that one of the benefits of doing this over, for example, the roll your own approach that was in the Mimi PR is that leaking the keys explicitly for a specific message is a little bit more of an issue for MLS. It seems like the kind of thing that you want to avoid the MLS stack being able to do gratuitously, whereas if it's baked into an MLS into an MLS wire format, it's a little bit safer. And so I acknowledge we would still want to encrypt the group info and the ratchet tree when sending it to the hub, but we're not trying to do that using keying material that is exfiltrated from the MLS key schedule.
So first of all, I think that there's a good improvement. When we first were working on MLS, we of course were saying that there's a single server and life's good. But with Mimi, we're looking at various other servers involved. And in some of the distributed cases, we may have even more. It may be very flexible. So the fact of being able to ask for, I'll say, updates to be handled by a particular DS, and even as a form of revocation where you could send updates or commits to one and then control messages to another later on, it gives us a lot more flexibility. That said, I also echo what Raphael mentioned as far as hiding the identities. It would be nice if there's some sort of recommendation with this about encrypting that as well, since it's kind of heading in that direction of how do we protect these control messages a little bit more. And the other point, which I do not have well formulated right now or thought out, is about the nonce and nonce reuse, particularly as this is a key for the DS and things are being encrypted to there from multiple different receivers. And it's something that might want to be considered or fleshed out, or just I'd like to hear what you've looked at regarding that.
Okay, yeah, I specifically the those four, the two pairs of of nonces and keys are individually encrypted for each external receiver using HPKE. So they have their own label. And the label is dependent on, if I recall correctly, it's dependent on the epic and group ID. So if you fork, then yeah, you could end up in a situation where maybe you have a 2-time pad, but I think it's pretty safe from the sort of obvious stuff. Okay, Conrad.
Yeah, I just wanted to second Britta and Raphael. I think this would be very useful to have in the toolbox for Mimi, of course, but also maybe generally in any sort of federated or relayed setting where you'd want to use MLS, but still keep the metadata leakage to one party that you then, or to some parties that you then chem the keys to. And of course, we can look at the cryptographic design and then make sure it's tight. But yeah, I think this should go.
Okay. All right, next slide. Other stuff. Whoops. Can you go to the last slide, please? No. Okay. Can you go to the second slide, please? just two enter might do it.
Oh, you want to go to the second slide? Like
The second slide. Yeah. Oh, there. Summary. That was good. Summary. Wherever that one. There we go. Okay, great. Okay, so I covered those three things. So I had a draft related to a MLS member proof. That was a bad idea. I'm abandoning that. There is something related to key package context. So this is something which, again, this has application state. So this might be something that becomes the kind of thing that is in a general application state extension. Everything that we need, that I think we need in Mimi for key package related stuff, I think you can do with this extension, but it's just sort of sitting on the back burner while we discuss other sort of more structural issues. We also do need a way in order to be able to convey the generic room policy, and that again, that's kind of tabled, waiting on the overall discussion of absent versus one or two other options, or some new combination. All right, and then not related to Mimi, the self-remove proposal that is currently in MLS extensions. There's no change there. I'd previously raised an issue that we may want to have external commits, an extension that allows external commits to incorporate proposals that were previously sent, pending proposals. I've received no feedback, positive or negative, on this idea, so I would welcome, anybody who wants to come talk to me privately about that, please do. Finally, we have this ratchet tree options draft, which I did. I just want to remind people that it exists. I think this discusses some useful ways to talk about changes to ratchet trees where you don't have to upload the entire ratchet tree or the entire group info in, for example, a welcome or when doing an external commit. And the last one is Britta's going to talk about, which is some post-quantum stuff. I have one draft which is related to a hybrid chem cipher suite, and this is blocked pending the output of the chem compilers design team in CFRG. They just announced sort of a way forward last week, and one of those ways will be a concrete combiner for a concrete combination of a classical chem and a post-quantum chem that we will probably build a cipher suite for. And there are other post-quantum approaches, and Britta's going to talk about one of those right now. Thank you very much.
Well, later, maybe. We might have run out of time on that. I'm sorry. we might have run out of time. So yeah, we still need to do this poll. So I think you're
Okay.
good. You're good now, and then we're going to hand off to Richard. He's going to get the balance of the time. We'll have to speed up a little bit. But Nick dropped some text in the chat room about what our interpretation is of the discussion that we had earlier was the first part of the discussion. So what it reads, if you're not in the chat room, the chair's interpretation is that there was an objection to the fact that the PR contained a high-level discussion of how to approach solutions to the problems raised, and the PR should only describe the problem. Brendan clarified earlier that the PR does not include technical details about solutions and that those should be left in the protocol documents. So what we're going to do is a show of hands. It's going to be 2 questions, yes or no. Yes for listing approaches and no for only including the problem. I think we've solved our technical problems. I can actually start this. Ta-da. All right, give it another minute. All right, what we got is 4 for yes, 8 for no, and 5 no opinions. But what I'm hoping is that you guys will get together and we'll figure out some text.
From the coffee will come answers,
Yes. All right, let me stop. Why is it doing that?
hopefully.
Of course, now I'm having a problem with Meet Echo.
So this is the section of the meeting where I talk about cool new stuff that we cannot adopt as a matter of IETF process because we were being held hostage by our area director on this architecture thing. But hey, it's fun to talk about cool new ideas anyway. And I'll try and be brief so that Britta gets some time.
This one. Here we go.
This additional credentials draft, same content as last time. We need some other new types of credentials for things like verifiable credentials. It's not a big draft. It's been around for 2 IETFs and people like it. And we had an adoption call on it where people said they liked it. Maybe we should just chuck this in the extensions draft. So I think, I forget who the authors on the extensions draft are. Maybe I should just talk to them.
Yeah, I mean, at this point, I don't know why we wouldn't, right? It's been sitting
Okay.
around long enough. So I would just ask Raphael, and if there's no objections, then like, we're standing on process. Let's get it done.
Anyone have concerns about that approach? Not seeing any concerned faces in the audience. All right, cool. This is actually new work. So we all love PCS, right? Sometimes you can't get PCS. If you send an update and someone else sends a commit without your update, you got to throw away the update. You lose your chance for PCS. So instead, replace. So update, right? You get the update, and it the way you know where to apply that update in the tree is based on who sent the message. This is just a proposal that says it in the proposal instead of in the envelope. What that means is if I'm a committer and I get a late update that shows up after I sent my commit off, the next time I commit, I can basically re-originate that update. I can say, instead of, it won't show up as an update, it'll show up as a replace. Instead of Imad saying, replace my leaf, I'll say, this is a leaf I got from Imad, please replace his leaf with that one. And in here, the leaf node has the same form as if it came in an update. It has to have that as its leaf node source, and it signs the same stuff so that you get some good authenticity to make sure that it came originally from the person that's being replaced. But really, syntactically, the only thing we're doing is adding that one little UN32 there. Next slide, please. So yeah, the idea that you can re-originate these proposals, like I don't know if folks have done this in their implementations, but you can do this to add and remove. Like if you get an add proposal, it doesn't get committed. The committer can create an add proposal with the same key package that will have the same effect. Same with removes. You say, oops, I forgot this remove proposal in the next commit. Here's a remove proposal in line that has the same effect. So this is just doing the same dance with update. When I talked to Marta about this, because she's a smart person, she pointed out that you can do rollbacks with this. So if someone has an update in an early epoch, and I can just like grab the key package from that update, even though they've committed 5 times and they've advanced the epoch. If I've like compromised the private state that goes with that old thing, I can use this replace proposal to roll that user back to the old compromised epoch. Not great. So the solution sketch that's in the document is to add an epoch. Track the epoch is the theme of the day, whether it's for your resyncs or for your replaces, right? So like, let's add an epoch to the leaf node. Leaf node extension says, I created this leaf node in epoch number n. So you can just check you're not rolling back like that. And in general, I think like I was saying earlier, like the idea here is to treat this as basically make sure that the order of operations is someone sends an update and I take the leaf node from that update and feed it back in. So kind of tightly coupling this mechanism with updates. That's the last technical slide. I think we got a little same like, what should we do with this? Like, do people think this is interesting? I think we've got a couple of applications interested in this for faster PCS and for some other use cases. Interested in folks on security risks and whether we do this as its own Docker extensions. Anyone have thoughts? Happy to have feedback on the mailing list as well. Raphael?
Yeah, just a quick one. So more PCS is always nice. I think we have to be super careful here, especially after the attack Brandon described earlier. It just demonstrates how brittle things can be. So yeah, we need a lot of scrutiny on that.
Yeah, for folks who do formal modeling, would love to incorporate this sort of thing in some of the models.
All right, the app isn't allowing me to raise my hand, so I'm just going to talk. So first of all, I think that there's a really nice functionality. If you can keep, and if we make a requirement there where that rollback is like 1 epoch back, then it seems like you gain a lot of functionality for not a whole lot of loss in PCS. Essentially, you're talking about 1 epoch. If you're talking about I'm rolling back 5 epochs or whatever, now we're beginning to really take a downgrade. So I think when we talk about the security here, it does need to be very clear in that discussion. But the functionality is nice.
Oh, so to be clear, the rollback I'm talking about is in the epoch comparison is the last time that leaf got updated. So if Rowan last updated in epoch 3 and issued an update in epoch 4, and then the group advanced to epoch 7, and now I'm taking that leaf from epoch 4 and I'm committing it on top of epoch 7, that would be allowed according to what's in here because his current leaf is at 3 and I'm updating him to 4. So I'm moving his leaf forward regardless of the fact that the group has advanced. Now, we could discuss like tying this leaf node epoch to the group epoch. That might be interesting as well. It would give you some tighter assurances with less reusability. But yeah, definitely happy to discuss that stuff.
Yeah, it's really that how far back you're going to reach for that update.
Yeah, that's a good point.
To the main question I have, which is actually item 3 here, it seems to me like this sort of functionality is more of a core part of the protocol. And there's a much bigger comment actually about all these extensions. Some of these extensions are really more fundamental protocol that we probably should be requiring for most implementations and not just an extension. It seems like maybe at some point we should be starting to discuss another draft and instead of accumulating more and more extensions. But I like the functionality.
And by that, you mean MLS 2.0.
How about 1.1?
Whatever.
Then we can have that discussion. All right. I think if Britta's got interesting stuff, I might just skip that one because we talked about this one last time and we can't really do anything with it. This one is big enough that we wouldn't just do it in the extensions documents. The idea here is that in large groups, downloading the ratchet tree and downloading full-size commits gets expensive. And so this document specifies how you can operate some clients without the ratchet tree. So you get lower authentication protections, same confidentiality protections, and you lose the ability, there's some trade-offs here. But you can operate with hard login guarantees instead of ideally login, but sometimes linear guarantees. So you get more efficiency at the cost of some functionality. Like I said, it's got real trade-offs. It's a fairly heavyweight mechanism. ironically. Heavyweight in terms of text, lighter weight in terms of client requirements. Would love to have additional collaborators on this. We've got a draft out there. But I think this is something we'd have as a separate document for the working group to adopt. So this is mainly just an advertisement for now. So get in touch if this is interesting to you. So the
Right.
balance of my time.
Cool. Yeah, I think we got time for PQMLS. There we go.
Okay, well, this will be a pretty short overview because I didn't make a whole bunch of slides. It's all nice and last minute here. So big question is, we're at a point in time where we should start talking about how to do post-quantum with MLS. We already have this X-Wing combiner that Rowan has proposed, which is very nice because it is one cipher suite, which is your standard or traditional, depending on what terminology you want to use, and your post-quantum, and per ratchet, you're going to do both. Now that combines it all very neatly. And it's nice if you are doing that very rarely. So if you're only every so often going to do an update, your whole update is going to be both. You do take in the overhead of both. But for some applications, if you can take on that computation, not too bad. Or if you're willing to take your PCS window and make it longer. Downsides, oh, we went to the next slide. So downsides of that are, of course, these overhead. And for a lot of lightweight uses or uses where you don't, especially when you begin to look at authenticity of post-quantum and you don't want to take on all that signature size, it begins to have an effect. So what are we proposing for doing about that? And there's another draft that's coming. We welcome people to be thinking about it and making recommendations. Talked about this at the last IETF, so there really shouldn't be any surprises here. And following that, had a bunch of discussion with different people about trade-offs and what you do in different implementations. And the short version is, how can we get the post-quantum to be still strong, but by keeping a very narrow ratchet on your traditional? So you get all your typical PCS effects, but you have post-quantum keying material in that key schedule, and you can control how often you update that. Big picture how this works is essentially you have two sessions. You have your post-quantum session and your standard session. And we're going to use an exporter key. So you take your post-quantum session, and you use an exporter key from that as a PSK into your standard ratchet. So what this is giving you is you know that that keying material has all your post-quantum guarantees. You're going to inject that into your traditional key exchange ratchet. And so occasionally you can do what we would call a full update, which is essentially much like the X-Wing draft. You have your standard and post-quantum at the same time. In between those full updates, you can do partial updates, which are just your standard ratchets, however often you want to set that continuity. So then it has a very fine-grained control about when you want to take on the cost of the post-quantum side and being able to have very tight ratchets on the standard side. So there's some DS, of course, sides that have to be figured out as far as you need some correlation between making sure that you have two groups, your post-quantum group and your standard group, and they know which ones to inject. But as far as what changes are needed, there's really not much changes at all to the protocol because you are just taking everything we already have as far as exporter keys and everything we already have as PSK, and you're matching the two up between your standard and post-quantum. So in many ways, we have all the functionality, we're just doing it in a very clever way. So that's the end goal as far as some of the pros and cons here. I don't think we really have time to go into any more of it, but if you are interested and want to discuss more what would be for your particular use case, come talk to me, and that draft will be coming out pretty soon.
All right, well, we still technically have 10
Questions?
minutes, so feel free to jump to the microphone if you do want to add anything. Otherwise, I'm just going to do go back to Raphael's slides, which we skipped. But go ahead, Raphael.
Cool. So let's see if I can actually see the slides. Yay, it works. Fantastic. So just one slide, really. Sorry if that's a disappointment. So yeah, I just wanted to give a really brief overview of what's been happening with the MLS extensions document. We had some previous discussions on one PR that has been merged about the extension state. So as a brief reminder, it's not an extension per se, but it's rather part of the safe extensions framework. And so it's guidance on how you can distinguish between state that can either be read or not by other extensions. So it's a measure to separate that. As I said earlier, there might be some overlap here with AppSync. And also that brings us to the next point here, and that is the group context extension update proposal. It's a bit of a mouthful. The idea there is that currently the way the spec is written, if you want to update a group extension, you have to essentially replace all of the content, whereas it might be much more efficient to only replace parts of it. Unfortunately, the author, who I believe is Franciscus, has not proposed any discussion on the mailing list, I think, or in any meeting. So we still need to wait for that. But to me, at least, it sounds like a sensible idea. And then lastly, Ron already mentioned that it would be nice to have a safe use of the additional authenticated data that currently has no structure whatsoever, and propose something that is rather straightforward by segmenting that with the appropriate extension ID. It just needs a little more of discussion because it's not entirely clear, since not structuring it is also valid. How are we going to deal with that specific bit? And we cut a draft after the last IETF, so once these issues are going to be resolved, we can cut a new one. And that's it.
So Raphael, I just want to make sure you heard that Richard's going to approach you about the additional credentials stuff, right? So he'll drop a PR.
I missed that part.
Okay, yeah. Yeah, he'll make a PR to submit it. Basically,
Cool.
that draft's been floating around long enough. We might as well just stick it in the extensions, the base extensions document, and just get on with it. Ron?
Hey, in what section does the extension state show up? Is it in safe extensions, or is it in?
It should be.
Okay. I can go dig for the PR, but I didn't see it in the editor's copy.
It's in the, yeah, it's in the merged PRs.
Okay. I'll look. Thank you.
Okay, so thank you. This brings our meeting to a close. Thank you for the lively discussions. Like the 4 or 5 of you that want to figure out how to fix that PR 261, let's get to it. That'd be great. I also want to thank Nick, who is backfilling for me because I forgot to ask for a note taker, so he took notes for us. So thank you very much, Nick. Everybody have a good day.
Thanks, man. Well, I'm going to go back over the recording.
Yeah, fair enough. Yeah, one of us is gonna have to do it. So, all right, cool.
Apologies for being late. I got
No worries.
stuck.